Go ahead.
Okay, so here is the list of the machine code implemented on this Wimp51 design. The first 10 were in the original design, and the last 2 were implemented to this design specifically. The first of these is a 2-byte subtract command, which subtracts a constant from the accumulator, and the second is the 1-byte subtract command, which subtracts the value of an internal register from the accumulator. The program implemented to demo this design is a 2-byte addition of 1001 hex from 9EFF hex, which will result in AF00 hex. That result, 1001, is then subtracted back from that result, give the original number 9EFF hex. So to start, we move 10 hex into the accumulator and store that value to the internal register 0 for future use. We then move FF into the accumulator, which is the lower byte of the original number, and subtract 1 from this, which is the lower byte of the number we are we add 01 to this, which is the lower byte of the number we are adding to this. We move the result into the internal register 1, and then we move 9E hex, which is the upper byte of the original number, into the accumulator, and add R0, which we had previously stored and is the upper byte of the number we are adding, to the 9E hex. Then we store that result in internal register 2 and start the subtract command. So we start with the lower byte. We move R1 into the accumulator, which was the 00 lower byte of the first result. We then subtract 01 from this. This will give us FF as the answer and throw the carry flag, which will subtract an additional 1 from the upper byte, subsequent upper byte. We then store the lower byte of the subtraction operation into internal register 3 and move R2 into the accumulator, which corresponds to the upper byte of the addition result. We then subtract R0, which is the upper byte of the number we are adding and subtracting from the original number, and move that result into internal register 4. We then move 9E hex, which is the upper byte of the original number, into the accumulator, and XOR that with R4, which is the upper byte of the subtraction result. This should be 00 if the answer is correct. So we have put a jump if 0, jumping to correct, which is here. Checking the second byte, the lower byte. If it is not 0 and it's incorrect, there's an S jump to the error loop down here. So assuming it's correct, we will go to here and move R1, which is the result of the lower byte of the subtraction command into the accumulator. We will XOR that with R3, which is the lower byte of the subtraction command, and we should get 00. Again, we're checking for an error, where if there is an error, it's not 0, it goes to the error loop, and if there is not a 0, it jumps to end, which is a forever loop doing nothing.
Okay, now let's test it.
Okay, so we're first moving 10 into the accumulator. So the accumulator is updated to 10. Just storing the upper byte for subsequent use. Now we can see that register 0 is updated with 10, so we've stored it. Now we're putting FF into the accumulator, which is the lower byte of the original number. And we subtracted,
Add 1.
we added 1 to the accumulator, which resulted in 0, as well as the carry flag being thrown.
Can you show me the carry flag? Where exactly is the carry flag?
This is the carry flag being thrown. So now we store that into the R0 or R1 internal register. Now we've moved 9E, which is the upper byte of the original number, into the accumulator. Now we've added the value of R0, which was 1029E, to get AF, which is the result, the upper byte result of the addition. Now we'll watch it update into R2. Now we've moved the result of the addition, lower byte result of the addition, into the accumulator, which is 0, 0.
Now we're going to subtract.
Yes, now we're going to subtract the lower byte, 0, 1, from 0, 0. We get FF. We also get a carry flag thrown.
Okay. And you move that to?
We'll move that to R3. We can watch it update. Now R3 is updated. Now we'll move R2, which is the upper byte of the addition operation, into the accumulator. AF. Now we will subtract the value in R0 from AF with the carry flag thrown to give us 9E in the accumulator, and we will store that value in R4. Now we start the check. We will XOR 9E and jump to...
Okay, is the 0 flag high?
Yes, the 0 flag is up, so it was correct. We jump to 1A, which is the next check of the lower byte. We move the value of R1 into A, which is FF. And we XOR that with the result to get 0. The 0 flag is thrown. And we move to a jump. It should jump to 23. And it does. And this is a forever loop that's alternates between 24 and 23 indefinitely.
Okay, great.